Well, hi, good morning. Thank you so much for joining me here in my shop. Today is August 27th. The sun is shining outside, but it's very cool. It's only 16 degrees outside, which is very cool. Especially here, August is usually very hot. But it feels like fall has come already to Ontario. So, this radio, this is day 2 for this radio. It's exhibiting a number of problems. One is it seems to be insensitive when it's tuned towards the low end of the band, more sensitive when tuned to the higher end of the band. It's an inconsistent operation across the tuning range. It's not receiving any signals, any stations anyway. Certainly is picking up noises and stuff like that. And it also is very garbled. Maybe it did pick up a station weekly. But the output's very garbled. I've checked the tubes. The tubes are okay. It's full of old parts, old capacitors. Looks like really nothing's been done to this radio. I also injected an audio signal basically into the volume control, and this revealed the fact that the audio remains garbled, and that suggests the garbling is taking place in the audio stages. There's 2 tubes involved. One is the detector tube. I think it's a 12SQ7 that has a triode audio amplifier in it, and then they have the output tube. And somewhere in that circuitry, a garbling is taking place. Now, the garbling sounds like 60 cycles or maybe 120 cycles being injected. The actual word, I believe, is intermodulation, or it's modulating the audio signal and giving it this sort of underwater kind of sound to it. That strongly suggests the problem is in the audio circuits for that particular part, the garbling. And I could go after that, but I think it's time for more fun. I try to take what for me is going to be a fun and interesting approach. Hope it's the same for you too. And here's an opportunity right here. All I've done so far is inject a signal, an audio signal, to make a determination. There's some other things I can do. I can inject I can listen instead of injecting a signal. I can listen to it. And look at this. I have this guy here is new to me, transistorized signal tracer, and you can't really see it, but it says common AF for audio and RF. So this is an RF and AF signal tracer made by Micronta. Micronta is a well-known maker of small devices like this. Now, is this working? So is there even a battery in there? I don't know offhand. So to find out if it's working, we have to feed a signal into it. And then I want to use this tracer to trace around inside the radio a bit. See what we can find out, assuming this works. If this guy doesn't work, I have 2 more tube-based, much better signal tracers. One of them can be used, and we can still do this listening to the signal as it passes through the radio. Try to hear where the garbling starts, even though I'm pretty sure it's in the audio circuits. So let's get a signal going here. What I'll do is I'll just turn this signal generator on, and we're going to hook the input to this, to the output from that. The signal is low. The radio is not switched on, or has no power applied to it. Consequently, we can ignore it. All I'm doing is just feeding the output right into this thing here. Okay, we'll put this on audio because this is an audio signal. Got some corrosion there. Turn it up full. I don't think we're going to hear a thing. We don't hear a thing. Okay, I'm going to boost the output signal from here. Hello. Nothing. My guess, it has a battery in it. It doesn't have a battery in it. That's my guess. So let's open this up and take a look at the fantastic Micronta transistorized signal tracer. There's no little door to put a battery in or out. Oops. So we got to do this. The weather prediction here is sunny for days to come. No rain in sight, but we've had a lot of rain up until now. And my tomato harvest is failing from what's called a disease. Oh, there's a lot in this. Oh, there is a battery sitting there. Oh, the battery is exploded. The battery is swollen. So yeah, this has got to go. This has probably been sitting in there. Oh, the whole top of the battery is just eaten right off. Well, that's the worst 9-volt battery I've ever seen. Wow, that's a mess. It doesn't seem to have done any damage in here, though. Which is pretty good. Do I still have another 9-volt battery? I must have one somewhere. Okay, I'm going to hunt down a battery. I'm going to clean this up and hunt down a... Oh. Did you not see any of that? Did I not show you this battery? Look at the thing. The top is completely shot. The clips are back in here. Even part of the battery that goes down inside is left behind. This is the worst case battery I've ever seen. I'll bet you it's been in there. Oh, there's a date on it. What did it say there? There's a special message on this battery. Best if installed by January 1998. Well, I'm afraid it's a little late for this guy. They were right. Okay, I'll clean up and find another battery. Well, this battery holder it's shot. If I get those pieces out of the clip, I don't think it's going to work out. But I have some new clips here. 9-volt battery clips I can put in, which I will. Wires I think are going to be long enough. It's just onto here. Oh, here we are. Just make these a little bit longer. Okay. Oops. Got nowhere there. These wires are so light. All I need to do is get some solder on that and I'm done. Just stay there. Don't go anywhere. Solder doesn't want to stick to the wire. Job. Oh, I need a 9-volt battery now. 9-volt battery. Well, I'm gonna have to buy some new 9-volt batteries. This is a used one, and its voltage is down around 7. That's kind of low. But it may work. Not so good. Uh-oh, we're getting nowhere here. Okay, this is going to go into the audio. Okay, we'll jack up the signal, coming over. 1000 hertz. There we are. Hear its own distortion though. The low battery may be introducing some distortion in this signal tracer. Jeepers, I don't know if we're going to be able to use it. But let's give it a try. So once again, I gotta clean up here and then we'll give it a try. Do you do this? When I'm going to put these screws into plastic, I turn them backwards until they do that. That's where they're falling into the groove, then I go forwards. That's to try to prevent cross-threading. Doesn't always work, especially if the threads have already been crossed up. There we go. Wow, there it is, the Micronta transistorized signal tracer. Ooh-wee. Now, what can we do with this? So, I'm not so sure. It's on audio right now. Why don't we try by start by listening to what the garble sounds like. How do we do that? Could put this on the, without hearing it come out of the radio speaker at the same time. That's just a little tricky. Well, maybe the relative volumes will be different. What I'll do is I'll put this right on the input. That's not going to work. What am I thinking? We should put it on the what if. So we don't know the input impedance of this guy here. Could be it's a really crappy thing. Now, it had a circuit inside there. It looked like somebody's done more than just hook the wires up to a speaker. So this is on the B minus. What if I try to put this, say, on the grid of the detector 2? So that would be the detector 2 there, and I have to do this. You're hearing what's coming to the grid, but the input impedance on this is bound to be not nearly high enough. Well, let's try it. Let's try it. This is all about try it and see. That's kind of the world I've come from. down. So we have a short on the antenna input, and I have a signal generator putting in a signal into the volume control. Okay, here we go. Turn the set on. Oops. And power it up. Just barely, I'll hold this up by the microphone. Okay, the radio's come on too. That's the sensitivity. It's not very sensitive. Not very sensitive at all on audio. So we'll put this on the grid. I have the feeling this isn't going to work out. Oh wait a minute. First we got to hear the sound. Hear the sound. Hear the sound. There's the sound. Okay, there we are. Oh, it's coffee break time right in the middle of this. Okay, I'm going to delay the coffee break. Now, how am I going to hear this out of here with this coming out of the speaker? Let's start right at the signal generator, just because we're trying to find out if this guy works too. Sprayed a little cleaner into the control here. Oh boy. So this is a pretty strong signal already. I don't think this is going to work out at all. It's just got no sensitivity. So that's what's going into the radio when heard through this. Getting overloaded. So it actually sounds pretty good there, but it's very quiet. I'll hold it up at the microphone again. But, okay, without changing the volume level. See, the great thing about this is battery operated. It's not connected to any kind of ground or anything at all. So it can be used in rather freely. I'm not going to hear anything out of this. Now the output of this is fed to the grid of the output tube. Oh, this is floating here. Danger, danger. Grid of the output tube. How am I going to get to that? So the output tube is here. I'm wasting my time doing this, but let's finish it off, and I can know what I've got here. The output tube is a 50L6. Maybe, yeah, I think weren't the two numbers marked on the schematic. Let me take a peek here. If I can. In numbers, very good. It's a 35. Oh, this is the wrong radio. Oh, I'm out of control. I'm out of control here. Yeah, I'm looking at the wrong schematic. Out of control. Let's stop for a sec. Oh, that's right, the coffee break. That's the problem. I didn't listen to the coffee break alarm. Okay, so I'm going to set this guy aside because I think I need to do some tests directly on it to get more comfortable with it. I'm going to go with instruments I'm familiar with, which is my signal tracer over here, which is a far better machine. This is a serious one over here. Warm this up. This has a bit of a hum in it, we'll hear in a moment. This is the input side to that signal tracer. There's actually a vacuum tube inside this handle. That's why it's so big. And this is just straight to the grid of that tube. So almost super duper high impedance here. Crazy high impedance. Going to operate the radio. You can turn it on now. Okay, the ground for the signal tracer is here, the ground wire, and it's connected to the B- on the volume control. That's where I connected it. I've got a loop here, and that's hooked up to this other signal generator, the one I usually use for doing tests because I'm very familiar with it. We're going to transmit a signal around a megahertz. We're going to pick it up with this radio, and we're going to trace around with the tracer and just see what we can see. And I'm not sure what we're going to find out here. That's going to be any different than what I already know. There's something going on in the audio circuits that makes the radio garbled. But let's see what happens. Okay, so we have a moderate signal on the loop right now, and I had to switch to this signal generator because it'll modulate the signal. This other one up here, it does not modulate the signal, so you never hear anything coming out of the speaker. Okay, well, I guess what we'll do, we'll turn the radio up, we'll tune it, and nobody home. So I'm tuning it right past 1 million on the dial. A little more juice. Oh boy. Oh, I know what's going on. I got a short. I still have a short on. I still have a short. Okay, turn it down. We'll take the short off. Okay, that's a little better. Now we hear something. Tune around, look for the signal generator. Wow. So this receiver seems to be sensitive at the higher frequency end of the band, and I'm right in the middle with 1 million, and it looks like it's just too dead there to pick it up. Well, I'll give it more juice. Wow. That's really surprising. Okay, let's dial up to, let's say, 1500 here. How about 14? I think that's around 14. I'm not actually sure from the dial. 14. Oh, it's just barely coming through. Wow. Okay, so I hear a garble, I hear a noise, and I can hear the 1000 hertz tone barely in there. So that's what's coming out of the speaker. But it could be the signal is passing through most of the radio just fine. It's getting wrecked somewhere later in the circuit. So maybe we can find this out. So this signal tracer, this much better one over here, can operate as an audio or an RF tracer. And we're going to set it up for RF. Okay. This switch has to be on RF. Now it's a radio receiver, but this is not a superhet. This is a TRF, a tuned radio frequency receiver. The band we're on, we want to be on the regular AM band, B. So let me put my finger on it over here. Okay, so I'm the antenna. That's what you're hearing, is me touching the doing that. Okay, we'll tune around. Some familiar noises that I hear in my shop all the time. That clicking, someone has sent me a note saying that a similar problem in their home, this kind of ticking noise, went away after tightening all the wires in the fuse box. Wow, I've never tightened the wires in my fuse box. Maybe I should. But boy, if that was coming out, if that's what's happening, what would be happening that would cause that in a fuse box? Anyway, that was his experience. Now, we want to tune this to around where the signal generator is, which is around 14 now. 14's way up here. pick up anything, not surprising. It's just my finger as an antenna. Okay, so we know this is around 14. What we'll do, in order to get things synced up, is we'll put this right on the output of the signal generator. Just one wire. This signal generator, this tracer has a volume control and also has an attenuator control. The attenuator control affects the magic eye, the volume does not. So you can set this and you can control things a little bit by using the magic eye as a set point. So if I turn this up just till the eye is closed, I now know there's a signal coming into the signal tracer sufficient to close the eye. It doesn't matter how loud I make it. Then as I trace the signal, I can tell if it's getting stronger or weaker by looking at this magic eye, which is what we're going to do. Okay, so we're going to put this back on. So that's what's output from the signal generator when connected this way. If you notice, the ground's not hooked up, but the ground may exist through my shop electric system of that. So we're going to put this back on the loop. Put it near the radio antenna. I'm going to try again to hear it. There it is. Tune a bit. Right there. Turn down the radio so we can't hear that. Turn up the tracer so we can hear that. Okay, now the antenna first comes in, and where does it actually go? Well, I know where it makes it to. It makes it to the grid of the first tube. So we're going to listen. So what's making it to the grid of the first tube? There it is. Tune the radio a bit. Big hiss. That's a big hiss. That's strange. You know what? That big hiss could be because I'm sticking this probe onto the grid. No, the big hiss is not coming out of here. It's coming out of over there. Let's move this a little further along here. Let's try. This would be. I'm not sure what that is. 1100. The dial markings don't follow the numbers very well. Like the dots don't follow the numbers very well. Okay. Turn this up, and then we'll crank this down to where we are. Last time couldn't hear it. Well, that's much better. Nice and garble. Lovely. Okay. Turn this down again. Ooh, careful. Got this funny on-off switch thing happening. Okay, top of that tube again. I don't hear a thing. Oh, it's because the other signal tracer is not tuned anymore. Too many things to tune here. Much weaker. Okay, so there we are. So you may not be able to see it, but the eye is wide open here. Now, when I tested the input signal, it was straight onto the signal generator wire. But I'm not connecting the wire to the radio, I'm using a loop. So how much is transferring from the loop into the antenna, we don't know. So is that a lower signal I'm picking up here just normal because of what I'm doing? Or is there something wrong with the radio already? Oh my gosh, look at this antenna switch. Oh, it's in the wrong spot all this time. Oh, ha ha. Okay, there we are. Fix the radio. It's all fixed up now. Let's have a listen here. Wow, that really boosted it. But you can really hear the garble. Oh my gosh, what a stupid mistake I was making. I guess it's only a stupid mistake if you don't figure it out. Otherwise, it's a smart mistake. Yes. Okay. Just wondering about the option of feeding the signal straight into this wire. Where's the metal? I don't know. Okay, trying to keep a focus here, Jim. Keep a focus. We're hearing the garble now. So we want to find out, where are we hearing the garble in the radio? So again, we'll go to the grid of the first tube and we'll listen for the garble. Even if I just get close here. So that's coming out of the signal generator. I'm just getting close to the tube. Lots more signal there. I gotta put that down. We need to watch the magic eye. Remember how strong the signal was? It was enough to close this eye, which you're going to have trouble seeing because of a light reflection. Who's reflecting on it here? Who knows? Too many lights in the shop. Okay, we'll have to go with what we've got. So it's wide open. Now I'm going to put it back on the grid. More than closed. That would suggest the signal is stronger on the top of this tube than it was coming out of the signal generator, but that's just a suggestion. Well, let's listen to it, Jim. You're supposed to listen to it now. I can turn this down a little bit. What's it sound like? Sounds beautiful. No garble. Okay. Now, we can go further in the radio. Well, the radio is now changing its frequency from the received frequency to its IF frequency. Oops, I moved this over here. Let's move this back. So now we want this to tune the IF frequency, and it can do that. I switched to band A. Now I'm on the top band, and the IF is 455, I'm guessing. That's 450. And that would be 460. So it's right in this area here. Okay. Now what I can do is I can touch the grid. Just rotate the radio here. We'll touch the grid of the IF tube. Way back here. And way back here. Okay, got some clip leads I shouldn't have out. I don't like having excess stuff on my bench, although of course it happens. I find the more stuff you got on your bench, the more likely you are to make a big mistake. Now, can you see anything when I do this? You run around the house with this, try to find out where that noise is coming from. Okay, enough of that. So, it's just whenever you get a little more antenna action on it that picks up the interfering noise. Okay, is anybody following any of this anymore? I'm having trouble. First we put this on here and we listen. It sounds beautiful. We tune this. What's that little quiet spot here? According to this, the IF is peaking around 430. It's not what I found yesterday, but maybe putting this on is doing that. Maybe. But no garble. No garble. Now we'll go to the next spot. So this is the grid of the audio tube where I was testing before with the other tracer. Now we got to make some changes here because we're no longer interested in the RF. We want to hear the audio. So we'll flip this over to audio. This dial doesn't mean anything anymore. Audio. What does it sound like coming out of the IF after detection? Right here. I'm going to turn this down because it might be quite loud. That's not what I expected. Ooh, that's feedback. Wow, how did that happen? That's a curious thing. How come no sound? How come no audio at all? Ooh, sorry about that. Turn this down. How come no audio at all? Because something's gone. Whoops, that was a mistake. That's what we should hear. Because I had the volume turned down. Right. Because we're into the audio signal, the audio portion. I had the volume turned down, there's no audio to hear. So we're going to compete here with volumes from the speaker here and the speaker from my tracer. So we'll try to win with the tracer. I'll turn it up a long ways. Not quite that high because of the feedback. Go on. And we'll turn it up. Oh, I turned the wrong knob, you dork. Not something you'd want to hear your airplane pilot say, that's for sure. Okay, now this is coming from the tracer. Not coming from there. How do I know for sure? Let me turn the tracer volume down. Yep. It's garbled. So it's garbled going into that tube. Great. I actually figured something out here today. Feedback again. Okay, so somewhere between the grid of this tube and the grid of this tube, a garbling takes place. It strikes me. I'm struck. I've been struck. I think we should look at the schematic a little bit. That might help with trying to take a guess as to what's going on here. Okay, let's put the schematic up here. I could not find a schematic for the radio that's on my bench anywhere. A Mohawk 1240. And I even looked for any reference that said the Mohawk 1240 is the same as something else. Couldn't find anything. Looked in my own books. Nothing. This is a company co-op. I don't think their brand got on many radios. So anyway, it's a fairly simple radio. It's going to be very similar to this one. This is the last radio I did, I'm pretty sure, although I've gotten thoroughly confused now about what radio is what and what is going on. But I think the similarity would be pretty similar. Pretty similarity here. So we'll look at this tube. This is the one that I touch the grid and I hear the garble. So the grid here is coming right out of the volume control. But I did not hear the garble here. But I can hear it here. That doesn't make a lot of sense. Let's try this again. I'm going to listen to the input to the volume control. See what we hear. There. Yeah, that was a long search I spent. I usually give up pretty quick on looking for schematics. Now, we want to listen to the volume control. Input on the volume control. The input on the volume control is going to be loud. What's happened here? We've lost the signal because I think I tuned the radio. There it is. Make doubly sure I will fool with the signal generator here. Yeah, definitely. So that's a 400 hertz tone garbled up by something. Now we're going to turn this down because we're going to listen to the signal that's coming into the volume control. Get my hand on the tracer volume here. Garbled. Garbled at the input to the volume control. But where else can we try this? RF output of the second IF transformer. that's practically the top of the volume control right here. A garbling sound like that often is a modulation of the RF signal, and that's going to take place in the RF tubes, the last one of which is the detector tube. Before we get to the detector tube, we listen to the signal going through the IF. It sounded just fine. So somewhere around the second IF transformer and the detector tube, something is going wrong there. That would get a 60 cycle-y sound in there. Now it could be there's a hum in the power supply here, and the hum is immaterial when you listen through the speaker. Well, I shouldn't say that. The hum itself is not driving this from the B plus of the output tube or anything like that. But earlier stages are more sensitive. Maybe a little fluctuation. Could also be coming from the heater string. The tube heater could be doing this. Now I changed tubes and it made no difference in terms of this garble. Didn't I? Or am I thinking of another radio? Oh my gosh, I've just totally lost it here. Yeah, I tested all the tubes in here. Found one weak, replaced it. Garble didn't change. Well, why don't we listen to the B plus? We'll listen to the B plus. We can do it on here. So we're going to listen to the audio on the B plus. I'll turn this down. I've never done this before. It might be maybe something I don't ever want to do. Okay. So the filter capacitor's down here. You can see leads coming off it here, there, and everywhere. Let's try this one right here. It might make a big pop. Oh, that doesn't sound good. Let's go over here. Same thing. Oh, that doesn't sound good. Nothing there. Nothing there. That's kind of funny in a way, isn't it? So these are all capacitors here. No hum. No hum. She's going wild. Gone wild. Well, okay, I think really that's the focus of the whole deal now. You know, it could be, you could have a hum, maybe from the power supply. That hum is sent into all kinds of circuits, and the speaker can only be in one place at one time. So it's going to have to amalgamate them all together. The radio is in some way, and maybe you get this sound, which is actually multiple hums on top of each other coming through in different ways because the hum is in the power supply. Well, that's a pretty basic lesson, Jim. I will do something about that power supply hum now. So I figure the first thing I got to do is get the value of the capacitor, but there's nothing written on it anywhere at all. That's not going to help. Don't have a schematic. Don't have the values. Often I'm just replacing it all with 50 microfarad capacitors anyway in a radio like this. Even the portion that might be just bypass on the output tube. Bias resistor in the cathode circuit. So if I put a big capacitor there, it doesn't really matter. So you just take all the three of these terminals and just, yeah, that's it right there. You've seen the action. That's the action. I gotta stop and drink some coffee. Okay, that's a good idea. It's the first good idea I've had, I think, this morning. And presto, it's the next day. What happened was I finished the last section of the video you just watched, and I left my shop and I went outside for a little bit, and I just never came back into my shop to do any more work yesterday because the weather was too fantastic. And I'm going to look out the window here. It's another fantastic day here. So So I want to get through this quickly. So guess what? I came in here and did something very unusual. No cameras running, and I worked on this radio. As a matter of practice, I virtually never do work on these things without the camera rolling, but I went ahead and did that. So here you can see the replacement capacitors for the main capacitor. You know, you have a couple options here when you do this, and then many or most radios require this to be done. You've got to get rid of this tired old capacitor down here. It's not doing its job anymore. There's a number of ways to approach this. I managed to use all the different ways here, I think. So you see I've lumped together 3 capacitors here. I've twisted together their common negative, and I soldered it down to the original negative terminal down here. And that gives the capacitors some rigidity. They're not flopping around. I don't have them on the end of a bunch of wires and they can flop around in the radio. They're fixed in place. And then, using a couple different techniques, hook up the rest of the wires. One of the techniques is to cut the wires off the old terminals and then move the wires onto the new capacitor wires. That's kind of straightforward. I did that here. I sort of did that over here. Just moved one wire. I moved this wire over to this terminal here. It comes back on this wire. The other thing you can do, and I've done this before, I just realized I left a tail in there, is you can get down with your cutters, maybe you need stronger cutters than these, and actually cut the terminals right off the old capacitor with the wires still connected. So you don't have to disconnect all those wires and then reconnect them. You just cut the terminal off, and I did that with this terminal. You can see the original wires and connections are all here, including a capacitor I'm probably going to change out at some point. You know, you might want to do those things at the same time. You know, if you're going to be close enough to a capacitor, maybe you want to change it right away. I'm doing this one thing at a time, and I don't want to change too many parts, or then I can't understand what I've done to the radio. If I play the radio and suddenly it works great, I don't know what it is I did that made it work great. And I'm always interested in knowing those kinds of things. So there it is. It's in place. It's 3 connections, and I use the same size capacitor here. Don't know what the size of this capacitor is. I never found a schematic, and there's nothing written on here to read. So is it really that critical? I think what was going on back in the day, and this will be going on today too, is the engineers designing these things are trying to use the lowest cost approach that they can get away with, because this radio is going to compete with other radios. So rather than put in the biggest and bestest capacitors that they can, they're putting in the smallest ones they can get away with within reason. And that's what this would represent. And we know electrolytic capacitors have a short life compared to other capacitors. So, and you know, the guys making this radio would know that, but they know that this capacitor's a little small, so if its capacity starts to go down, it won't be long before the radio won't behave properly. But how long? 15 years. Well, by 15 years, for crying out loud, this thing will be in the dump, won't it? Well, here it is 90 years later. Never made it to the dump, and I'm pretty sure after I do this, it won't be heading for the dump. Well, who knows? Who knows how long? Oh, I just realized something. How long these radios are going to survive into the future. You know, if you've got a shop and you're doing this kind of work, you are preserving these things into the future for at least 10, 15, 20 years, maybe much, much longer, maybe hundreds of years. It sounds crazy to say that, but it's possible that this radio will still be around hundreds of years from now, and I don't think I will be. So I did hear something fall out of this radio earlier, and I didn't investigate, but now I see the tube just dropped right out. When I turned it upside down, the tube fell out of this socket. And I know this one was a little bit loose. This is the output tube. Just dropped right out. Sylvania. Okay, so that means the tube is in here pretty loose, and maybe it's going to act up a little bit because of that. So that's the only change I want to make to the radio right now. Don't think I need this. What we're going to do is we're going to play the radio and hear that the garble is gone. At least that's what I think is going to happen. and we'll have de-garbled the radio. And I believe really what we're hearing is something that is called intermodulation distortion, and it's occurring. It's not just that the hum, if you like, is coming out of the speaker. It is coming out of the speaker, but if you don't hear, if there's no program material, you don't hear a hum. The hum is embedded in the program material, the voices and the music and stuff like that. I think that's true. Sounded good to me. I like that explanation. I'm going to run with it. So put this tube in and discover just how loose it really is. It just falls in. Okay. Well, I don't know. It's so surprising. That fell out. That's surprising. That's not coming out. Maybe I never put it all the way in. Okay. No problem though. Time to fire up... Hey, if you ever wonder what kind of videos I watch on YouTube, I do not watch any videos about radio repair except the odd one. Occasionally, there's a particular topic, and occasionally, but very occasionally, I do not watch other people's radio repair videos, which might be apparent because there's some things I could probably learn from the other people that I'm not learning. What do I watch? I watch a lot of geology videos. I've discovered here at this point in my life, later in my life, that geology is a very interesting topic. And I live in an interesting area for geology. In fact, you probably do too. Everybody in the world probably does. But only the geologists know it. So, as I've learned more geology about the area I live in, we have the Niagara Escarpment not far from here. We have the Great Lakes not far from here. The Canadian Shield not far from here. And just a short drive from my house, a 5-minute drive and a 10-minute walk, and I can stand, and I've done this, and I've got a video on YouTube of me doing this. I stand on a flat rock, look down, and just see a field of fossils embedded in the surface. It's fantastic. You look down, and there's all these animals from 460 million years ago. There they are. I'm standing on that surface. So there's lots more very interesting things that have gone on here. Sheet floods under glaciers. There's a huge number of oh my god, I forget the word for it. Son of a gun. How do you like that? A formation that occurs under glaciers where the soil is built up into this funny whale-type shape. How can I not think of the name of it? Okay, I'm drawing an old man's blank right now. Probably come to me in a couple minutes. Anyway, the bottom line is there's just all kinds of geological things of interest, and the more I learn, the more interesting it all becomes. Today I was watching a video on the Great Unconformity. Great Unconformity is where you have a rock surface. You can in places in the world you can find it, you can stand on it, and above that rock surface, which is everywhere in the world, there's something like 1 billion or 1.5 billion years of rock gone. So if you find some rock sitting on top of it, there's a time gap between this layer and this stuff of 1 billion years of Earth's history rubbed out, ground down, and washed into the oceans to be lost forever. Isn't that something? That's really something. And you can find this thing in different parts of the world, especially here in North America. There are some places, interesting places, where you can go and actually stand and look at this Great Unconformity, which you can type that into Google and find out more about it. All this stuff's very interesting. That's what I watch because I get enough electronics here in my shop and doing my ham radio and all that kind of stuff. I don't need more of it on YouTube too. I got to do something else. I want. Yeah, there's other things too. I'm talking too much. I'm not doing anything. Let's turn this radio on now. Okay, since I worked right on the power supply, the chance of me having made a mistake is pretty high. Or let's say the implications of having made a mistake when working in the power supply are much greater than working in other parts of the radio. capacitor here or there. So I want to be very careful and make sure I use the dim bulbs when I switch this on. What's going to happen? Now, new capacitors, new charge, and big ones. I didn't mention that. I don't know what the size of the old ones were. Probably 20s, 30s, 50s. I don't know. I put in 350s. 350s because they're so cheap today. Here we go. Okay, that was perfect. That was perfect light behavior there. Excellent. What would have freaked me out is if these lights came on full tilt and stayed that way for a period of time. If putting in bigger, potentially putting in bigger capacitors, draw more current, especially during the initial charge up, and maybe pop something. And one of the things that can be put at risk is the rectifier tube itself. But no concern here. No concern. So we're going to try to pick a station up and listen for the garble. That sounds nice right there. No hint of garble. Here we come. I have successfully removed the marbles from the mouth of this radio. So that's probably 680. Maybe not. Might have been 640. Are they talking about sports? Yep, they're talking about sports. Canada 2-0 at the Worlds. Hey, Canada did very well at the Worlds this year. So, good show. No garble. Now, frankly, it's been in the back of my mind the whole time I had this radio going, and I heard the garble right at the start. I thought, well, it's got to be from the capacitors I just changed. But then later, I had some indications that suggested, no, it's not from there. And that's why I didn't change them until this point in the process. So, but generally speaking, a radio this age with the original power supply filter capacitors, they're going to be bad, and especially if they're there. Well, that's it for this video. Thanks a lot for watching. I don't know what I'm going to do with this radio next. Try to assess its performance, try to assess where there's a weakness. I'm not anxious to get in, just change capacitors willy-nilly. If the radio is actually working fairly well, I'm more inclined to leave it as original as I can get away with. Let somebody 20 years from now or 30 years from now work on it and have the same exciting experience I'm having. And hey, they could even find my videos on YouTube, because I expect those to be around for 100 years. Why not? And maybe, that's interesting. I'll stop thinking about all that stuff. You see, this is what happens when I look at geology stuff. I start thinking in terms of millions of years and stuff like that. So I don't think this is going to be around 1 million years from now. Okay, well, thanks again for watching, and I'll see you on the next video tomorrow.